Hi, in this video, you'll be learning about angles. Now, consider this basketball player. For him to make a good throw, he will need to make his throw at a good angle. We form angles in several of our activities. Can you think of some? Like taking a stairway, cutting a piece of material, or even reading a clock. These are various ways we form angles. You'll be learning angles formed by parallel lines, angles in a triangle, and also angles in a quadrilateral. Now let's take angles formed by parallel lines. Alright, consider these lines AB and CD. You'll notice that these lines are pointing in the same direction. So even if we extend them forever, they will never cross or even get close to each other. When two lines are arranged like this, you call them parallel. Now, you have probably heard of the term parallel before, like parallel parking, parallel universe, or parallel bars. Okay, so parallel lines are lines that never meet or never cross. But what about if we take one of these lines and give it a little nudge? Now the lines aren't parallel anymore. In fact, they cross at this point here, P. When lines cross at a point, we say that they intersect, and the point is called an intersection. When lines cross at a point, they form angles. So, you have angles that are formed between the spaces. Call them 1, 2, 3, and 4. But instead of calling them 1, 2, 3, and 4, in geometry, we name them by the points used to make them. For example, this angle here is called DPB. Because if you trace along this point, it forms that angle. Also, you also have the point APD, which forms an angle ADP. Now we can replace this angle with an angle sign like this. There is another way of naming angles. Imagine that the line segment between the 2 points of intersection can rotate around, just like a clock rotates around the center of a circle. Now let's imagine that we can rotate this line segment through the point, and it leaves a part as if a pencil was attached to it. The part that is left when we rotate the line segment all the way around forms a circle. But if we only go a part way around and it forms part of a circle, that is called an arc. This arc forms an angle between the two lines. Now if we shrink the arc so that it is close to the point of intersection and then put a letter by it, then we have another way of showing an angle called angle A. If we do the same with this order space, we have angle B. Alright, answer this question before we go on. Yeah, when two lines intersect, they form 4 angles. That is, 2 pairs of vertically opposite angles. Now imagine that we know one of these angles to be 95 degrees. We can easily get the remaining 3 angles by using vertically opposite angles and angles on a straight line. So you have 95 degrees. It's vertically opposite. Now if you consider this straight line, 180 minus 95 will be equal to 85 degrees because angle on a straight line is 180 degrees. Hence, this angle will be 85 degrees because they are vertically opposite. Now answer this question before we go on to learn some cool skills. Alright. Now if we replicate this line and move it up slightly, the angles created on the new line will be exactly the same as the angle on the bottom. Now, corresponding angles, alternate angles, and allied angles are just a way of describing this concept. The idea that the angle you get at the top are the exact same angles you get at the bottom. Also note that a line that cuts two parallel lines is called a transversal. In this example, you're asked to find angle A. Now, let's use the skills you have developed so far. At the bottom, you have angles on a straight line, hence 180 minus 120 will be equal to 60. Then the other two angles will be 60 and 120 degree because they are vertically opposite. Now, you know that the angles at the top will be exactly the same as the angles at the bottom. But this is a long method of doing this. You need a more simple and efficient way to do this. You can see that a lot of the angles are the same. When you get to angles that are in the same relative position, you call them corresponding angles. So, the two that are highlighted are corresponding angles because they are the top and the right side of the transversal. And there are other corresponding, as you can see, being highlighted. So you also have alternate angles. When you have angles that are opposite each other of the transversal, you call them alternate angles. Here is some examples to describe this. In this question, you are asked to find angle B. You can tell angle B is corresponding to 118 degrees because they are on the same position of the transversal. Corresponding angles are equal, therefore B will be equal to 118. Now the second question, you have been asked to find angle A and B. Angle A is alternate to 37 degrees because they align in the opposite side of the transversal. Alternate angles are equal, therefore A will be equal to 37 degrees. Now angle A and B lie on a straight line. Angles on a straight line is equal to 180 degrees. Therefore, to get B, you just simply minus 37 from 180 degrees, and that will be 143 degrees. That will give you the value of B. So B will be equal to 143 degrees. Now, here are some questions on your screen. I want you to tell which ones are corresponding or alternate. I'll give you some seconds to think about that, and then I'll tell you the correct answers. Okay, now here is an example. You're required to find x. You would notice that these are not corresponding angles, neither are they alternate angles. So what are they? They are allied angles. Allied angles add up to 180 degrees. They must be between the parallel lines. So x will be equal to 180 minus 110, which is 70 degrees. Also, in this example, you have been asked to find y. Similarly, these are not corresponding or alternate angles. It is an allied angle, Therefore, y will be equal to 180 minus 27, which is equal to 153 degrees. Alright, before we look at some more questions, answer this question. In this example, you're asked to find angles A, B, C, and D. Now this looks like it's a bit more complicated than the ones we have solved, but it's not really. Note that the sum of angles in a triangle is 180 degrees. So, when you look at this, you immediately notice a triangle. To get angle A, take away the other two angles from 180 degrees. Therefore, angle A will be 180 minus 54 minus 50, and that's 76 degrees. So A is 76 degrees. Following up on that, I can see we have a straight line, and I know that those two angles must add up to 180 degrees. Therefore, 180 minus 76 degrees will be equal to 104 degrees. B is 104 degrees. Now, if I turn this diagram, you will easily notice that angle B and angle C are allied. That means they add up to 180 degrees. Can you see that? So, C will be equal to 180 minus 104, and that's 76 degrees. So C is 76 degrees. And then angle D is an alternate angle to angle B. Therefore, D is equal to 104 degrees. Yeah. Now, let's look at one more question before we take an example on quadrilateral. In this question, you're asked to look for A, B, and C. You must have noticed that angle C is corresponding to 117 degrees. Therefore, angle C is equal to 117 degrees. Now, B and C are on a straight line, and we know that that adds up to 180 degrees. Therefore, B will be equal to 180 minus 117 degrees, and that is 63 degrees. So B is 63 degrees. To get angle A, notice the triangle underneath the bottom parallel line. To get the adjacent angle to 117 degrees, subtract 117 from 180. That will give you 63 degrees. Now the other angle of the triangle is a right angle, which is 90 degrees. To get angle A, you have to add 90 plus 63, which is 153. And then subtract it from 180 degrees, which is 27 degrees. Therefore, A is 27 degrees. We are almost done here. Let's take a look at quadrilaterals. A quadrilateral is a four-sided shape. That means four straight lines meeting together forms a quadrilateral. There are different types of quadrilateral, for example, rectangle, rhombus, and a square. They are all quadrilaterals. Now you must note that the sum of angles in a quadrilateral adds up to 360 degrees. The sum of angles in a quadrilateral adds up 360 degrees. This is very important to note because you'd always use them. Now, before we proceed, I want you to answer these questions that follow. Okay, so
So in this example, you're required to find x in this quadrilateral. Do not forget that the sum of angles in a quadrilateral add up to 360 degrees. So to get x, you would have to add up the other angles, which is 100, 95, and 60, and then take it away from 360 degrees, and you get the value of x. Or you can just say 360 minus 60 minus 95 minus 100. Therefore, x will be equal to 105 degrees. Now you've come to the end of this video. Please attempt the exercises that are underneath this video to gain mastery of this topic.